Hello. And intro to most of my instructional videos here is going to be just some basic things to keep in mind. One, I record and I record my videos and post them to YouTube so you can use closed captioning. I know I tend to talk a little fast, so hopefully this will help. You can see down at the bottom of the screen here what you can see in English what I'm saying. The other thing you can do with closed captioning is if you want to see it in another language, let's say you can read Ukrainian or you can read Spanish or Filipino. Oftentimes YouTube will allow you to do closed captioning in another language, so that can be helpful there. That's a resource there. The other thing as you're watching these is pause. Don't be afraid to pause the video. Write down what you're doing or write down your question and then restart it again. That's something that's a little bit different than in class because I know I do tend to talk fast. All right, as you're watching these videos, I want you to break it into 3 parts. Part number 1 is to watch that video all the way through, get an idea of where you're going. What are the expectations? What is it you're going to be doing? If possible, what's the end product? What's the end result you're putting there? What is it you need to have done? Second is to put together a notes, and that's where you're taking these on paper and pencil. I know a lot of you like to take notes digitally or want to take notes digitally. It's not the same. I really encourage you do it as your handwriting. It helps with making that connection between the brain and what's going on. And as you're taking notes, take notes on things instructions that I give you. Write out those instructions. If I give you hints or tips, write those down. If there's important measurement information or details, write those down. Also, questions, write down your questions. Words you don't understand, directions that don't make sense, things I don't demonstrate. Those are great. Write those off I would encourage you, write those off to the side in the margin. And then the next step, third time you watch the video, is go back, watch for things, do I answer the questions you have? Look for the answers to those questions. Because any questions that are left afterwards, that's when you can email me at my email address that hopefully will pop up here if I do it right. Or you can save them for when we're in class. All right, so hopefully these tips and instructions are going to be helpful, and I look forward to helping and supporting you. So let's go ahead and get started. And as I always say, let's go forth and do some great things. Hey, welcome back. Good afternoon, good evening, good morning, whenever I may be finding you. We're here for our week 5 of our Coder Z instruction online robotics and programming. So I want to take a quick second to review data blocks, loops, and the use of radius. So find ourselves back in Candy Town, I believe. Nope, not Candy Town. That's this week's lessons. This is Lost City, I believe, or something to that effect. I'm not going to worry about it too much. Okay, so we've got our turn here, and this may be I think the last one I demoed. So we've got I'm going to zoom in a little bit here and see if I can't recenter that. No, it's not going to let me. Okay. So anyways, let me just go full screen on that bad boy. All right, so as I look at this, I've got, I want to talk about use of data blocks. So we've got a 6 here, looks like a measurement here, distance from, let's say here, back to here would be, well, the full of that is 6, looks like 3, maybe starting here, 3 back, let's say 3, 4 back here. We could measure it to there, so it's probably 2, so maybe back 4, whatever. So we've got that, and then we've got our turn of 105 degree angle, and that's a degree. Okay, so as hopefully you figured out, we've got we got to drive forward, we got to turn, we throw a turn in there, but then we also got to back up, and then we've got to turn. I'm going to say turn to the right. So we've got we got to go angle and distance, turn for distance in there. Just to remind you there with your data block, all data think of data as a number and a whole, well, an integer or a, just a degree. That's all data blocks are, is just input that you're putting in. Okay, so we have our forward 6, our backward 4, and maybe we want to put in a, before it backs up, maybe we want to put in, there's another data block there. We want to put it in there for maybe 2,000 milliseconds. It waits until it backs up to give the piece a chance to turn. Okay, and then we're going to turn right. I think, was it negative 105? Oops, not negative 195, 105. And let's just, I forget, it's been a while since I've done this one, but let's go ahead and run the simulation here and see what happens. But there it's, so it hits the button, and now it's waiting, and then coming back, and then, nope, wrong way, stop, don't run off, we'll go reset the simulation, and we'll do a left turn there. All right, now we'll run it, and I think that will do what we want it to do. But again, we've just got the, simple there. Oh, I want to go Explorer view. There we go. And then, I could complete the turn there. All right. The last thing, let's say, let's go to another one of those. I'm going to go to, nope, I don't want to restart. I want to go to back to the Learning Center. And I wanted to, I think this is the one I want to go parallel detour here. Now you'll notice I've got a lot of forward, left, forward, right, forward, left, forward. To complete that, I could, if I wanted to, forward, left, forward, right. No, that's not the one I wanted. Let me go back here and see if I can find that really quickly. Let's see here, parallel, sharp turns. What I do want to hit you with or show you is the use of, this is one here. So we've got a forward turn, forward 3. It doesn't really work here, but let's say we wanted you to go all the way down that and then back up, all the way down and back up and then back up. We could use a repeat block, and we just throw in a data block with the number of times. That would be repeat forward, so forward, set our data, and then backwards, and then turn, and we could go forwards, backwards, turn, and then forwards, movement forwards, and then we could repeat that. So we go forwards, backwards, turn, forwards, backwards, turn, and continue on if there is more to it than that. So that's just the repeat block. In this lesson, we're going to have a couple more, in this week's lessons, we're going to have a couple more vocab. I'm going to go into some math to talk about the, you'll want to know and review, and it's something that I know some of you 7th graders have been into, the parts of a circle. So in the first part of this lesson, we'll talk about vocabulary and the parts of a circle. Okay, I'll see you in part 1. All right, welcome to part 1, and I'm going to jump over to, let's see here, where am I going? No, not to my mail here. Let's see here. There it is. So here we are in the Fabulous Math is Fun site. We're going to be talking about the parts of a circle here, and the parts that we're going to use are what's called a radius, which is just basically from the center point of the circle to the outside edge, and the circumference. The circumference is the pi times the diameter, pi times the radius squared. That'll give you the area. The important part also is the arc. That's the distance of the curve. That's your degrees. Okay? So really, this does a great job of identifying the parts. But the important part is radius, and the reason for that is in this lesson we're going to be making what's called smooth turns. And these are a little bit faster than the other turns that are out there. they're kind of more like a car, whereas these you're watching the robot one tire stopped and it's turning. We call those swing turns, or similar to a pivot in basketball. Now we're going to kind of turn around you could do a point turn, just turning around a center point. This is going to be more of a smooth turn. All right, so I'm going to jump into the, let's see here, for this one, it's going to be the Candy Town. So that's the kind of the vocab for part one. Part two, we'll demo a couple of these, kind of walk through them with you. And so look forward to seeing you in part two. Hey, welcome back for part two. All right, so in this part, we're going to demo mission 1 and mission 7. And I'm going to try to cut this down a little bit. This one, so let's jump into mission 1 here. So mission 1 is really simple. We're going to jump into Explorer view, and you can see we're just going to do a nice little radius. Here's our radius of our circle. It's a radius of 1, and you can see this is a half circle, so we know that the degree is 90. Okay, so because we're just turning 90 degrees. If the target was over here, it would be, what was that? Did I hear you right? 180? Yes, that's right. Nice. All right. So just jumping into P code for that. So we know we've got an angle of 90 degrees and a radius of, what was it? I believe 1. Yeah, so a radius of 1. So that's what the P code, or the pseudocode, would look like. You can get a kind of a jump start on mission 7 there if you want to. So to do these, we're just going to pull out a turn. We're going to set angle and radius. And now I know that from my P code I'm doing a right turn. So I'm going to adjust that to the right. And then I'm going to pull out my data blocks and pop those in there and just simply do a 90-degree turn at for 1 radius, and let's run that. And there we go. And you can see there that I'm just going to pop in and try this again here. So what it's telling the robot to do, really, if you want to get into the engineering part of things, is it's saying make your right 90-degree turn using a radius of 1. What that radius does is, I'm going to jump into Explorer view, it adjusts the power to both the right and left motors so that it's doing a smooth turn like a car. Okay? And not like in the past where we just had one motor off. Let's see, for a right turn, one motor off, and then that left motor swung. This is what we call a swing turn. It's swinging, or like a pivot in basketball. This is more like like I said, like a car, but it's more like a point turn where you're turning around a center point. You could make it so that it turns like so, but this is more of a smooth turn. The nice thing about these turns are they allow you to kind of speed up your programming a little bit. All right, so I'm going to jump into the Learning Center, and in the next part, I'm going to talk about mission 7, which will throw in some repeat blocks. All right, welcome to the next part here. So let's jump back into Learning Center. Mission 7. Okay, Slither. All right, this one is going to be a little, you can see by my pseudocode earlier that we're going to have to run some repeat blocks. And I know I'm going to do some repeat blocks because I've got, let's see here, one turn to the left, one turn to the right, and then I repeat that, another turn to the left, another turn to the right, so that I know I can do a repeat block, and I've got to repeat it 2 times. So rather than doing 1, 2, 3, 4 lines of code, I'm only doing 1, 2, 3 lines of code. And that's kind of the goal with programming, is you want to be efficient. So let's go back to our P code here. And so I'm going to repeat this 2 times. And now, as I look at the angle here, I'm doing a 180 degree turn. So I got that 180 degree turn, but here I'm doing looks like here I got to do a measurement, and let's make a measurement here, and let's pull this in and find out. Yeah, okay, so that's 2. So that looks like to be my radius of 2. And so let's jump back in, and I know some of you are probably going, no. Okay, 180 and 180. Okay, and let's just say it, radius of 2, radius of 2. I'm going to tell you right now, this is not correct, but I want to show you what happens when we do that. So we're going to go, and we're going to go through our repeat block, and we're going to repeat this twice, not 12 times. Okay, and then we're going to get our turn to the right, turn to the left, and then our second turn, and we're going to set these up here, angle, 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 radius, excuse me, and then we're going to throw in our data blocks. Now, I'm doing this incorrectly to kind of show you, to illustrate a point, because I know some of you are probably going to do this. You hurry through things and you're going, okay, great, got my radius. Okay, so 180, 180, and 2, and 2. And all right, perfect, run it. And here we go. So I'm turning, and wait a minute. There goes my robot. Stop, stop, stop. So those of you who weren't figured out, I'm going to reset the simulation here. As you're looking at this, you may be saying, well, okay, they told me to measure 2. Yeah, you're right. They told you to measure that. But the problem is, if you were to take this top half of the circle and this bottom half of the circle and slide it together, that's actually going to be a diameter. You want the radius, which is 1. Okay? So let's try a radius of 1. And I'm going to go back. Now I love how some of you have been doing this little trick here, Alt F, Alt Shift 5, and right here, Alt Shift 5, and then coming back and going at 1, and then let's see, let's just do another Alt Shift 5, and come out here and go Alt Shift 5, and go 1. I love how some of you are actually going in and doing the strikeout. That gives me a good idea of what your thinking is. So if I was to change that to 1 and run it, you would see that, oh, there we go, nice smooth turn, nice smooth turn. Oh, wait a minute, helps if that one's set to the right. Okay, so we'll set that up here, and we go, we'll just run this one, and we'll speed things up here to 4 times. You can see there it is, nice little turn, and I made it. Okay, so that's one way you can use the repeat block to kind of just make your code a little bit more efficient. All right, for this one, you're going to be doing, I'm going to return to the Learning Center. You're going to be doing all 10 missions. I want to see, and this one I want to have you do some, I want to see your pseudocode for all of these, so for all 10 missions. Okay, I gave you, it's for mission, the first few missions, it's going to be the same, going to be very similar, but I really want to see that pseudocode to see how you're problem solving through these, because I know, open loop, especially this symmetrical round and this round maze, they can be quite complex and kind of confusing, and the pseudocode kind of helps break it down for you. Also, as we get close to the end of this, you're going to need to use your pseudocode to problem solve through things, and I'll explain that in about a week or so. All right, good luck. I can't wait to see how you do and how you get through things, and go forth and do great things.